Hi friends, my name is Radhakrishna and I am the head of the JEE Math Department in Cracku. In this video, we shall be presenting the recorded solutions of IOQM paper. The idea of this video is to help the future IOQM aspirants in their Olympiad journey. You may pause the question initially, try to solve it on your own and then watch the video solution for optimum growth. If you have any doubts on any of these questions, please do comment below this video. We look at all the comments and we shall try to answer to the best of our ability. And do check out our JEE Foundation course in the description below. Let us begin. Question number 1. 60% of a number x is 40. 60% of x is 40. What is x percent of 60? X percent of 60. You can clearly see that this product and this product are one and the same. So we'll have the same value here also. So the answer to this question is 40. Find the number of positive integers n which are less than or equal to 100, which are divisible by 3 but not divisible by 2. So we want multiples of 3 but not multiples of 2. That means we want odd multiples of 3. So let's find 3 into 1, 3 into 3, 3 into 5. These are the odd multiples of 3. The last odd multiple of 3 is 99, which is 3 into 33. So 1, 3, 5 and so on. These are odd multiples. 33 is 17th odd number. So we have 17 multiples of 3 which satisfy the condition. So the answer is 17. The area of integer sided rectangle is 20. So imagine a rectangle with integer sides. M and n are natural numbers. Its area is 20. What is the minimum possible value of its perimeter? So here we have possibilities 1 into 20, 2 into 10, 4 into 5, 3 possibilities. The perimeter is twice of m plus n. So we need to look at the minimum value of the sum of m and n. Here the sum is 21, here the sum is 12, here the sum is 9. The minimum value is 9. Put 9 here. We get the value 18. That is the answer for the third question. How many isosceles integer sided triangles are there with perimeter 23? Let us say the equal sides have length m and the third side has n. The perimeter 2m plus n is 23. Apply triangle inequality here. Sum of two sides should be greater than third side, or 2m is greater than n. Add n on both sides. 2m plus n is greater than 2n. This is the perimeter 23. So the maximum value of n is 11. So and one more thing, if you observe this is even number, this is odd number, and this has to be odd number. So how many odd numbers are there till 11? We have 1, 3, 5, 7, 9 and 11. 6 possibilities. Therefore, the answer is 6. How many 3-digit numbers of the form ABC in base 10 are there with A not equal to 0 and C is equal to A plus B? So we have a 3-digit number ABC. The first digit is non-zero. Last digit is sum of the other 2 digits. So here the minimum value of C is 1 because A will be minimum 1. So let me put C is equal to 1. I have only one pair 1, 0. If I put C is equal to 2, this could be 2, 0 or 1, 1. If I put C is equal to 3, 3, 0, 2, 1 and 1, 2 and so on. If I put C is equal to 9, I'll get from 9, 0 to 1, 8. The total number of possibilities is the sum of first 9 natural numbers, which will be 9 into 10 by 2 or 45. That is the answer for the fifth question. The age of a person in 2025 is a perfect square. So let us say the year of birth is X. So what will be the age in 2025? 2025 minus X. This is age in 2025. Is saying this is a perfect square. Let us call it M square. M is some integer. His age is also a perfect square in 2012. His age in 2012 will be 2012 minus X. This is also a perfect square. His age will be a perfect cube M years after 2025. In 2025, his age is this. After M years, let us take M naught here. After M years, his age will be 2025 minus X plus M. He's saying that this is some perfect cube. We want to determine the smallest value of M, this number. So first we'll substitute these two equations. To eliminate X, we get M naught square minus N naught square is equal to 13. Difference of two squares is 13. Look at the squares. 0, 1, 4, 9, 16, 25, 36, 49, 64. Here the difference is 13 and nowhere can you see a difference of 13. So we have 49 minus 36 or M naught is 7, N naught is 6. Put it here. X will be 2025 minus M naught square or 2025 minus 49 or 1976. We got his year of birth. Substitute this here. This is nothing but M naught square. So M naught square is 49 plus M is equal to K cube. The smallest cube after 49 is 64. So M should be 15. That's our answer. The sum of two real numbers is a positive integer n. So let us say the real numbers are x and y. Their sum is n and this is a positive integer. The sum of their squares is n plus 1012. What is the maximum value of n? So we want the maximum value of n. Now look at the structure. From x plus y and x square plus y square, we have to eliminate x and y. So we'll use Cauchy-Schwarz inequality. I'll take two vectors. One vector is x and y. Another vector is 1, 1. Apply Cauchy-Schwarz inequality. A bar dot b bar whole square is less than or equal to mod a bar square into mod b bar square. Dot product is x plus y. So here we get x plus y whole square is less than or equal to mod a square is x square plus y square. Mod b square is 1 plus 1, 2. X plus y is n. So this will become n square. X square plus y square is n into n plus 1, 0, 1, 2. So we get n square minus 2n is less than or equal to 2, 0, 2, 4. Add 1 on both sides. We get n minus 1 whole square is less than or equal to 2025, which is 45 square. So n minus 1 is less than or equal to 45 or n is less than or equal to 46. So the maximum value of n is 46. A quadrilateral has 4 vertices A, B, C, D. We want to color each vertex in which we have 4 colors: red, blue, green and yellow, so that every side and the diagonal AC have endpoints of different colors. In how many ways can we do this? Let us see. We have 4 colors: A, B, C, D and diagonal AC. These 5 line segments should have different colors at endpoints, opposite endpoints. So let us say B and D, we don't know, they can have the same color or different color. So I'll take 2 cases. B and D have different colors. B and D have same color. So let us say A, I'll color with one color. B has to have another color. So this, let us say this is color 2. C has to have another color. Now it cannot be 1 or 2. So it's a different color. Now D cannot be 1, cannot be 3 and cannot be 2. So it has to be 4th color. So 4 colors I am rearranging in 4 positions. So the number of rearrangements is 4 factorial or 24. Second case. A I can color with, let us say, color 1. B should be different. Let's say color 2. C should be different. Color 3, it should not be equal to A also. B should be same as D. So this color will come here and our condition is satisfied. So A's color I can select in 4 ways. B and D's color I can select in 3 ways. And C's color I can select in 2 ways, which is again 24. So total number of ways is 24 plus 24, 48. That's the final answer. Four sides and a diagonal of a quadrilateral are of lengths 10, 20, 28, 50 and 75, not necessarily in that order. Which among them is the only possible length of the diagonal? Let us see. We are given 4 sides and 1 diagonal. Let us see if 75 can be a possible value of the diagonal. If I put 75 here, 50 should come somewhere. Let us put 50 here. Now, according to triangle inequality, sum of 2 sides should be greater than third side. At 50, the sum should be greater than 75. So this should be at least 26. There is only one other side which is more than 26. So here I have to put 28. So the other two should come here. But this triangle is not possible because sum of 2 sides is less than the third side. So 75 cannot be your diagonal. Similarly, let us check with 50. With 50, 75 will be somewhere here. If I put the smallest side 10 and the other two largest sides here, again this triangle is not possible because sum of 2 sides is less than 50. So 50 is also not possible. Let's start with the smallest side, 10. Now 75 will come somewhere here. We'll use the other version of the triangle inequality. Difference of 2 sides should be less than the third side. So 75 minus x should be less than third side. That means x should be at least 65 or 66, more than 66, 65. And we don't have any such values. So this triangle also is not possible. So 10 is also not possible. Let's check with 20 as the diagonal. Now 75 will come here. If I call this x, 75 minus x should be less than 20. So x should be greater than 55. I don't have any other side which is greater than 55. So this is also not possible. So the only value which can be a diagonal is 28. That should be the answer. Let us cross check. Now if I put 10, 20, this triangle is possible. If I put 50 and 75, this triangle is also possible. The only length among them which can be the diagonal is 28. The height and the base radius of a right circular cylinder are positive integers. So the height and the radius are natural numbers. Its total surface area is numerically equal to its volume. Total surface area will be equal to volume. Total surface area will be 2 pi r into r plus h. Volume is pi r square h. I can cancel pi r. We get 2r plus 2h is equal to rh. I can simplify this as minus 2r minus 2h plus rh is equal to 0. Add 4 on both sides. This will factorize to r minus 2 into h minus 2 is equal to 4. So this could be 1 into 4, 2 into 2 or 4 into 1. So what are the values of r and h? R comma h will be, we need to add 2 here. Here it will be 3 comma 6. Here it will be 4 comma 4. If I do plus 2 here, it will be 6 comma 3. If volume is k pi, what is the smallest value of k? So k pi is pi r square h. We want the least value of r square h. So in the first case, it will be 9 into 6, 54. Second case, it will be 64. In the third case, it will be 108. The least value is 54. That's the answer.
If the love for math has kept you this far, you can get enrolled in our JEE Foundation course with IITian faculties from top 7 IITs and years of experience. The course has 100 plus live classes, 250 plus concept videos and 5000 plus practice questions with detailed solution. Do check it out, linked in the description below, and happy learning.
Consider a fraction a by b which is not equal to 3 by 4. A and b are positive integers which are co-prime. B is less than or equal to 15. If this fraction is closest to 3 by 4 among all such fractions, then we need the value of a plus b. So consider the difference a by b minus 3 by 4. This difference should be smallest. We have to minimize this because it has to be closest to 3 by 4. I can write this as 4a minus 3b by 4b. Now I have to minimize this. If I have to minimize this, I have to minimize the numerator and maximize the denominator. The maximum value of the denominator will occur when b is equal to 15. So this will become 60 here. 4a minus 45. So what is the least value of 45 and a multiple of 4? The closest multiple of 4 to 45 is 44. That means a should be 11. The sum of a and b will be 26. That's the answer. Consider the 5-digit positive integers of the form a, b, c, a, b that are divisible by the 2-digit number a, b but not divisible by 13. What is the largest possible sum of the digits of such a number? So let us call this n. N is a, b, c, a, b. So I can write this as the 2-digit number AB into 1000 plus C into 100 plus the 2-digit number AB. Now let us call this value M. M plus 1000 M is 1001 M plus 100 C. So this is the value of N. Now this is divisible by the 2-digit number AB. The 2-digit number AB, which we were calling M, this divides N, and this is not divisible by 13. 13 does not divide n. Now if you observe, 1001 is 11 into 91. 91 is 13 into 7. So this part is a multiple of 13. So if 13 is not dividing n, since 13 is a factor here, 13 should not divide 100c. 13 should not divide 100c. 13 and 100 are co-prime. So 13 should not divide c. The only digit here is 0, which is a multiple of 13. That means c can be any value from 1 to 9. Now let us go to the other condition. The 2-digit number AB divides n. Now m divides this, so m should divide 100c. Now what do you want? We want the sum of the digits. The sum of the digits is 2a plus 2b plus c, and we want the largest possible value. So we want to maximize this. So first we will maximize c. Put c is equal to 9. This will become 900. So I need the 2-digit number which is a factor of 900, and the sum of digits should be largest. So let us focus on factors of 900. 900 is 100 into 9. Let's look at the 2-digit factors. The smallest 2-digit factor is 10. 10 into 90. Then I'll have 12. 4 3s, 25 3 75. Then we'll have 15, 60. Then 18. 9 2 is 18. 2 into 25 is 50. 20 into 45. Then we'll have 25 into 36. Then we have 30 into 30. These are all the 2-digit factors of 900. Now I have to maximize the sum of the digits, this part. So let us see where a plus b is maximum. 1, 9. Here I have 12. Nowhere else we'll have 12. So AB can be 5 7 or 7 5. So this will be 2 into 5 plus 7 plus 9. 12 to 24. 24 plus 9 is 33. That is the answer. Three sides of a quadrilateral are 4 root 3, 9 and root 3. The sides A and B enclose an angle of 30 degrees, and the sides B and C enclose an angle of 90 degrees. If the acute angle between the diagonals is 80 degrees, what is the value of x? We are supposed to find the acute angle between the diagonals. Because I have a 90 degree here, let's visualize the right angle. B is 9, C is root 3. So what I'll do is, I'll consider this as the origin. This will be 9 comma 0. This will be 0 comma root 3. A and B included angle is 30 degrees. So A will be here. This will be 30 degrees. So this will be the diagram. Now using parametric form of a line, I can find the coordinates of this point. I know the starting point, the inclination is there, and the length is there. So this will be 9 minus 4 root 3 into cos 30, comma 0 plus 4 root 3 into sin 30. So it will be 2 will get cancelled. 9 minus 6 is 3. This will be 2 root 3. So I got the fourth vertex also. So I want this angle. Let us say the slopes are m1 and m2. m1 is 2 root 3 by 3 or 2 by root 3. Slope of the other diagonal will be minus root 3 by 9 or minus 1 by 3 root 3. Acute angle between them will be mod of tan theta will be mod of m1 minus m2, minus of minus will become plus by 1 plus m1 m2. So here if I multiply 3, I get 6 plus 1 7 by 3 root 3 into 9 by 7. This will be root 3. So x degrees is 60 degrees. The value of x is 60. That's the answer. A function f is defined on the set of integers such that for any two integers m and n, we have this functional equation. And f of 0 is 1. Determine the largest positive integer n such that sum of the first n f of k is less than 100. Please observe this functional equation. F of mn plus 1 is equal to fm fn minus fn minus m plus 2. This is true for all mn. So I can interchange mn also. So if I interchange m and n, I'll get f of nm plus 1 is equal to f of n f of m minus f of m minus n plus 2. Subtract these two equations. This will be the same, it will get cancelled. This will get cancelled. You get 0 is equal to minus fn plus fm minus m plus n. This will get cancelled. Or f of m minus m is equal to f of n minus n for all mn. That means f of x minus x is a constant, or f of x is x plus constant. We are given an initial condition, put x is equal to 0 here, f of 0 is 1. So we got k is equal to 1. So the function is x plus 1. So this part will become, when I put k is equal to 1, I'll get 2. When I put k is equal to 2, I'll get 3, and so on till n plus 1. Provide 1 on both sides. The sum of first n plus 1 natural numbers, n plus 1 into n plus 2 by 2 is less than 101. N plus 1 into n plus 2 is less than 202. If I put n is equal to 12, let us say, this will be 13 into 14. This will be 182, which is less than 202. So 12 is a valid value of n. If I put n is equal to 13, this will be 14 into 15. It will be 210, which is greater than 202. So from here on, n values are invalid. So the largest value of n is 12. That is the answer. There are 6 coupons numbered 1 to 6 and 6 envelopes also numbered 1 to 6. The first 2 coupons are placed together in one envelope. Similarly, the third and fourth are placed together in a different envelope. And the last 2 are placed together in yet another different envelope. How many ways can this be done if no coupon is placed in the envelope having the same number as the coupon? So let us say these are the coupons and these are the envelopes or boxes. Now these 2 go into one envelope, these 2 go into one envelope, and these 2 together they go into one envelope. Now 1 and 2 cannot go into 1 because 1 will be matching. They cannot go into 2 because 2 will be matching. So this combination should go in any of this. So let us say 1, 2 go to either 3 or 4. Let's say this set. I can choose one envelope in 2 ways. Let us say I chose 3. Now for 3 and 4, you can either go to the set of 1 and 2 or set of 5 and 6. Let's take two cases. Let us say 3 and 4 go to the set of 1 or 2, one of these. So let us say I can select 1 in 2 ways. Now 5 or 6 can't go here or here, they have to go here or here. So I have 2 ways. So in this case, I have 8 possibilities. Now what we'll do is, the second case, 1 and 2, let us say they go into 3 or 4. This is again 2 ways. Now 3 or 4, let's say I'm selecting 1 and 2 is going here. 3 or 4, instead of going to 1 and 2, let's say they go to 5 and 6. You can select one of them in 2 ways. Let's say this is over. Now 5 or 6 can't go here. They can go here. There is a space, and here there are 3 spaces total. So it can go here or here or here. So 5 and 6, there are 3 ways to go into an envelope. So how many ways? 2 into 2, 4, 4 into 3, 12 ways. So the total is 20. Now this is when 1 and 2 is going to 3 or 4. Similarly, I can do 1 and 2 going to 5 and 6, wherein I'll get 20 more cases. The total is 40 ways. Let f of x and g of x be polynomials of degree 2 such that this condition is satisfied and some initial conditions are there. We want the value of f of 5. Now please observe this. By looking at this, I will construct a function f of x minus f of x by g of x minus 4. Let us call it some h of x. If I simplify this, f of x minus 4g of x by g of x. Now what will be h of minus 2? This will be f of minus 2 by g of minus 2, which is 4. 4 minus 4 is 0. Similarly, h of 3 also will be 0. So when I put 2, minus 2 and 3, this will become 0. If you look at the numerator will be a quadratic. So that should be 0. So f of x minus 4g of x is a quadratic with roots minus 2 and 3. So I can write this as lambda into x plus 2 into x minus 3. So look at these values. Put x is equal to 7 here. We get f of 7, 12, minus 4 into g of 7, minus 6, is equal to lambda into 7 plus 2, 9 into 4. 24 plus 12 is 36. 36 is getting cancelled off. You get lambda is equal to 1. So from here we get f of x minus 4g of x is x plus 2 into x minus 3. Now substitute x is equal to 5. When I put x is equal to 5, f of 5, which is what we need, minus 4 into g of 5, which is 2. 5 plus 2 is 7, is 2. So f of 5 is 14 plus 8, 22. That's the answer. MTAI is a parallelogram. MTAI. The area is 40 by 41 square units. MI is the reciprocal of MT. So if I call this length L, this will be 1 by L. Similarly, this will be L. This will be 1 by L. If this angle is theta, the area will be product of adjacent sides into sine theta. This is L into 1 by L into sine theta. So we got the value of sine theta. If D is the least possible length of MA, so this length is D. D square is A by B. We want mod of A minus B in simplest form. So here we'll apply cosine rule. So we get d square is equal to, this will be pi minus theta, L square plus 1 by L square minus 2 into L into 1 by L cos pi minus theta. This is L square plus 1 by L square. If sin theta is 40 by 41, this will be 9. Cos theta will be 9 by 41. Here, we don't know whether this angle is acute or obtuse. So this will be plus or minus 9 by 41. But what we want the least value. So we'll go with a minus so that this will be reduced. So this least value will be 2 here minus 18 by 41, or 82 minus 18 by 41, which is 64 by 41. So the difference here is 64 minus 41, 23. 23 is our correct answer. Let n be the number of 9-digit numbers that can be obtained by permuting the digits 2, 2, 3, 3, 3, 4, 4, 4, 4. We have 2 2s, 3 3s and 4 4s, and which have at least 1 3 to the right of the rightmost occurrence of 4. So let us see. We have 9 places, 2 2s, 3 3s, 4 4s. The total number of arrangements will be 9 factorial by 2 factorial, 3 factorial, 4 factorial. From this, we'll subtract the occurrences where after 4 there is no 3, because he's saying after 4 that should be at least 1 3. That's the complement of after 4 there is no 3. So let us look at the cases. The last digit could be 4, in which case this digit is over. There is no 3 after that. The remaining 8 digits can be arranged in 8 factorial by 2 factorial, 3 factorial, 3 factorial ways. The last 4 can be here. After 4, 3 should not be there, so I have to put a 2. So 1 4 and 1 2 is over. The remaining 7 digits I can arrange in 7 factorial by 3 factorial, 3 factorial ways. The last 4 is occurring here. After that, 3 should not be there. So these 2 2s should be there. The remaining 6 digits I can arrange in 6 factorial by 3 factorial ways. And that is what you can do. Here, all 2s cannot come because there are only 2 2s. So these are the only 3 cases. So this is going to be our answer. Let us simplify. 9 factorial by 2 factorial, 3 factorial, 4 factorial minus. I will take 6 factorial by 3 factorial, 3 factorial common. Here I get 7 into 8 by 2 plus 7 plus 1. So 9 factorial by 2 factorial, 3 factorial, 4 factorial minus. This is 20 into 28 plus 8, 36. So if I simplify this, 9, 8, 7, 6, 5, 4 factorial will get cancelled off. 2, 2, 3. So 6, 8. What about this? 36 into 35 minus 720. I can take a 36 common. This will be 20. 36 into 15. 15 6 are 90. So we get 540 ways. What is the remainder when n is divided by 100? The answer will be 40. In triangle ABC, angle B is 90 degrees, AB is 1 and BC is 2. Consider a right angle triangle. B is 90 degrees, AB is 1 and BC is 2. On the side BC, there are 2 points D and E such that E lies between C and D. We have something like this. E lies between C and D. And DEFG is a square where F lies on AC. So DEFG. This is a square. So these four sides are equal. This entire thing is 2. G lies on the circle through B with center A. So A is the center, B and G will be equidistant from A. So these two will be same. This is 1. So this also will be 1. If the area of DEFG is m by n, where m and n are co-prime, what is the value of m plus n? So we need the area of this particular square. So we'll assume B as the origin, C will be 2, 0 and A will be 0, 1. I can write the line equation of AC. I have the x-intercept 2, y-intercept 3. The line will be x by 2 plus y by 1 is equal to 1, or x plus 2y is equal to 2. This is the x-axis. So I'm assuming coordinates of D to be alpha 0 and E to be beta 0. So this length will be beta minus alpha, which will be the same as the other three lengths. This also will be beta minus alpha. So what will be F? F's x coordinate will be beta, y coordinate will be beta minus alpha. This point should lie on this line. So substitute x plus 2y is equal to 2, or 3 beta minus 2 alpha is equal to 2. We got one equation in alpha and beta. Then similarly, G will be alpha comma beta minus alpha. This will be 1 unit from A. So we have AG square is equal to 1, or write the distance formula, alpha square plus beta minus alpha minus 1. Beta minus alpha minus 1 whole square is equal to 1. Alpha square plus, in place of beta I'll substitute this, 2 alpha plus 2 by 3, that is the value of beta from here, minus alpha minus 1 whole square is equal to 1. Let's multiply the whole thing by 9. 9 alpha square, inside you multiply by 3, plus 2 alpha plus 2 minus 3 alpha minus 3 whole square is equal to 9. This will be 9 alpha square plus minus alpha minus 1 whole square is equal to 9. I can put plus here. 1 plus 9 is 10, plus 2 alpha, 1 minus 9 is minus 8, or 5 alpha square plus alpha minus 4 is equal to 0. So from here we get alpha is equal to minus 1 and 4 by 5. Now here alpha should be positive because it is to the right of 0. So I will discard this root and I will take this value. Let's look at the value of beta. Beta is 2 into alpha plus 1 by 3 from here. So this will be 2 by 3 into alpha plus 1 is 9 by 5. 3 threes. So I'll get beta as 6 by 5. We want area of the square. M by n is, the side is beta minus alpha. So this will be beta minus alpha whole square. Beta minus alpha is 2 by 5. Whole square will be 4 by 25. So I got my m and n. What do we need? We want the value of m plus n. M plus n value is 29. That's the answer. Let f be the function defined by f of n is remainder when n power n is divided by 7 for all natural numbers n. Find the smallest positive integer t such that f of n plus t is equal to f of n for all natural numbers n. So let us start. f of n plus t is equal to f of n for all natural numbers n. This is true for all natural numbers. So I'll put n is equal to 7. So I get f of 7 plus t is equal to f of 7. So let's look at this. What is f of 7? This is remainder when 7 power 7 is divided by 7. This is a multiple of 7, so remainder will be 0. So f of 7 will be 0. So here I got f of t plus 7 is equal to 0. What is f of t plus 7? This is the remainder when t plus 7 whole power t plus 7 is divided by 7. So we want this is congruent to 0 modulo 7, because when you divide this by 7, remainder is 0. This particular thing, if you open using binomial theorem, first term will be t power t plus 7. Everything else will have 7, so we'll ignore that because we are doing modulo 7. This will be congruent to 0 modulo 7. That means this should be a multiple of 7. This will happen only when t is a multiple of 7, because 7 is a prime here. Or you can write t is equal to some 7k. So we'll put this in the first equation. F of n plus t is congruent to f of n for all n belongs to n. So we have n plus t whole power n plus t is congruent to n power n for all n belongs to n. Now this I can write as n plus t whole power n into n plus t whole power t is congruent to n. We are doing everything in modulo 7. From here I can write n plus 7k whole power n into n plus 7k whole power 7k is congruent to n power n. This one first term is n power n. From second term onwards everything will be a multiple of 7. So we can ignore that. Here I can write n plus 7k whole power 7k is congruent to n power n. This will reduce to n plus 7k whole power 7k is congruent to 1 modulo 7. This is true for all n. Now from Euler's theorem, we have n power 5 of 7 is congruent to 1 modulo 7. 5 of 7 is the Euler's torsion function. 5 of 7 is 6. So n power 6 is congruent to 1 modulo 7. If you compare these two, we get 6 is dividing 7k, because we are going with smallest positive integer. We'll write 6 divides k. So the least k I can have is 6 itself. So t will be 42. That is the answer.
Solving IOQM math questions is fun, and the same goes with JEE. To build on this curiosity, we have launched our JEE Foundation course for classes 8th, 9th and 10th with IIT faculties from top 7 IITs and years of experience. The course has 100 plus live classes, 250 plus concept videos and 5000 plus practice questions with detailed solutions. Do check it out, linked in the description below, and happy learning.
For some real numbers mn, a positive integer a, these three numbers, they consist of 3 consecutive integers written in ascending order. So this will be of the form lambda minus 1, lambda and lambda plus 1. What is the largest possible value of m square? So we need the largest value of the middle term. We will take these two terms. The difference should be 2. So a into n plus 1 whole square minus a plus 1 into n square should be 2. Expand. an square plus 2an plus a minus of an square plus n square is equal to 2. This will get cancelled off. 2an plus a minus n square is equal to 2. Send everything to the right hand side. N square minus 2an is equal to a minus 2. 2 I am sending to the left hand side. Add a square on both sides. Left hand side has become a square. This will be a square plus a minus 2. This is an integer, so this will be a perfect square. So I am calling this sum k square. This part I can write as a plus half whole square minus 1 by 4 multiply by 4. I get 2a plus 1 whole square. This is minus 9 is equal to 4k square, or 2a plus 1 whole square minus 2k whole square is equal to 9. Difference of two squares is 9. Let's see. So these are some squares. After this the difference will be more than 9. So I have one possibility here, one possibility here. So this could be 9 minus 0 or 25 minus 16. So let us see. 2a plus 1 will either be 3 or 2a plus 1 will be 5. In this case, a is 1 or a is 2. So if a is 1, I'll substitute it here and I'll try to get the value of n, or you can substitute here. So I get n minus 1 whole square is equal to, if a is 1, this will become 0 or n is equal to 1. If a is 1 and n is 1, here I'll get 2 into 1, 2. Here I'll get 1 into 2 square, 4. So the middle number will be 3. This will be the value of m square. In this case, if a is equal to 2, substitute here, I'll get n minus 2 whole square is equal to 4 plus 2 minus 2. This will get cancelled off. I get n minus 2 is 2 or minus 2, or n is 4 or 0. Let us put a is equal to 2 and n is equal to 4. This will become 3 into 16, 48. Next term should be 49. And this one will be 2 into 25, that is 50. If I put n is equal to 0, this will be 0. This will be m square. This will be 1 into 2, 2. So here m square will be 1. The different values of m square are 3, 49 and 1. He's asking the largest possible value, so we'll go with 49. That is the answer. There are m blue marbles and n red marbles on a table. Arman and Babita, will call them A and B. A and B play a game by taking turns. In each term, a player has to pick a marble of the color of his or her choice. A starts first, and the player who picks the last red marble wins. For how many choices of m and n, where m and n are lying between 1 to 11, can Arman force a win? So we are starting the game with Arman, and Arman has to win. Winning means picking the last red marble. Now please understand here. Let us say this is the first player picking one marble. After this, if I have even number of red marbles and even number of blue marbles, the guy who is picking next will always lose, because if he picks red, the first guy again will just copy him. If he picks blue, this guy will again copy him. So what matters, what happens now is, he'll always gets the last red. So after picking the first one, if there are even number of red and blue, the guy who is picking here will always lose. That means the guy who is picking the first one will always win. So for Arman to win, after the first pick, there should be even number of reds and blue marbles. This one can be red or blue. So that guy will pick whatever is the extra one. For example, this extra one, if it is red, we have odd number of red marbles and even number of blue marbles. So that Arman, what he'll do is, whatever is the odd number, he'll pick it first. Now you will have even reds, and whatever Bhavita picks, he'll just try to copy. In that way, he always gets the last red. Similarly, if that extra marble is of blue, we will pick blue first, and from here on, it will be just copying the other pair. In this case, in this way, Arman will always pick the last red marble. But there is a special case here. If the number of red is 1, Arman, when he is picking the first one, he'll directly pick a red and he'll win in the first turn. In this case, blue can be anything. We don't care whether blue is even or odd. So here I have 11 cases. After one, if number of red balls is 3, 5, 7, 9 or 11, blue should be even. So we have 2, 4, 6, 8 and 10. So we have 5 into 5, 25 possibilities. If R is even, 2, 4, 6, 8, 10, blue can be any odd number, 1, 3, 5, 7, 9, 11. This is 5 into 6, 30 cases. So total we have 55 plus 11, 66 cases. So that is the answer. Let ABCD be a rectangle. Let's call this ABCD. Let M and N be points lying on AB and BC respectively. Let us say this is M and this is N. Assume that MC is equal to CD. MC and CD, these two are of equal length. And MD is equal to MN. MD is equal to MN. These two are of equal length. The points CDMN lie on a circle. CDMN lie on a circle. That means these 4 points are concyclic points. If you imagine a circle passing through them, we have a diagram something like this. C, D, M, N. Now this is 90 degrees. That's an angle of a rectangle. So cyclic quadrilateral, opposite angle is also 90. And sum of these two will be 180 again. So I have angle DMN is 90 degrees. We want AB by BC whole square. So let us say this is A and this is B. We want A square by B square. If I join DN, this will be the diameter of the circle because angle in a semicircle is 90 degrees. Let us call this angle theta. If this is theta, this also will be theta. Angles in the same arc. So angle CMN will also be theta. Now this is 90 degrees. This theta. So this will be 90 minus theta. If this is 90 minus theta, this will be 90 minus theta. Now look at triangle DMN. This is a right angle triangle and isosceles triangle. So we have 45 degrees here and 45 degrees here. If this is 45, this is also 45. Angles in the semicircle, angles in the same arc. If this is 45, this is naturally 45. If this is A, this is A. Look at triangle MBNN. See, this is a right angle triangle and I have 45 here. So it's a right angle isosceles triangle. So if this is B, this also will be B. So we have B here, we have B here. So this length will be B root 2. And he is given that this one and this one are one and the same. So we have A is equal to B root 2 or A by B is equal to root 2. We want A square by B square. We have A square by B square is 2 by 1. This is M, this is N. M plus N is asked. So the final answer is 3. P of x is a polynomial x power 2025. Q of x is this polynomial biquadratic. R of x is the remainder. When you divide P of x by Q of x, we want R of 3. Let's look at Q of x. Q of x I can write as x power 4 plus x cube. This will split into two terms, x square plus x square plus x plus 1. From here, if I take x square common, I get x square plus x plus 1 plus x square plus x plus 1. You have a common factor, x square plus x plus 1 into x square plus 1. So we are able to factorize Q of x. I can clearly see the zeros here. Here I get plus or minus I. Here I get omega and omega square. Now let's write Euclid's division algorithm. X power 2025 I am dividing with Q of x, x square plus 1 into x square plus x plus 1 into some quotient plus remainder R of x. I am dividing by biquadratic. So this will be having degree of at most 3. So I'll assume R of x to be ax cube plus bx square plus cx plus d. That's it. Now substitute x is equal to I. I have I power 4 is 1. This is congruent to 1 modulo 4. So this will be I. This will be 0. And from there I get a into I cube, which is minus I, plus bi square, which is minus b, plus ci plus d. Compare the real parts. 0 is equal to minus b plus d. So I got b is equal to d. Compare the imaginary parts. 1 is equal to minus a plus c. So I have two relations here. Now I'll go with omega substitution. If I substitute x is equal to omega, this is a multiple of 3, so this omega cube will become 1. This is 0. Here I get a into omega cube, that is a, plus b omega square plus c omega plus d. This I'll write as 1 is equal to, a will write as c minus 1 from this equation, plus b omega square plus c omega plus d is same as b. So this 1 will become 2. b into 1 plus omega square. 1 plus omega square is minus omega. C into 1 plus omega, that is minus c omega square. Let's expand this. 2 is equal to minus b into omega value is minus half plus root 3 by 2 into I, minus c into omega square value is minus half minus root 3 by 2 into I. Compare the real parts. 2 is equal to b plus c by 2 or b plus c is 4. Compare the imaginary parts. 0 is equal to root 3 by 2 into minus b plus c. So I got b is equal to c. We already have b is equal to d, so these three are same. The sum is 4, so each of them is 2. So b, c, d are 2 and a, which is c minus 1, should be 1. So what is your R of x? A is 1. All other three coefficients are 2's. We want R of 3. So R of 3 will be 27 9 2 is 18, 6 and 2. So we have 33 plus 20, 53. So the answer is 53. For how many numbers n in this set 1 to 37, can we split the 2n numbers 1 to 2n into n pairs ai, bi's such that product of all ai plus bi's is a square? Let us see what it means. If I put n is equal to 2, 2 is here, I'll take 1 to 4. 1, 2, 3, 4. Can we split this into pairs so that product of all sums is a perfect square? So what I'll do is, I'll take 1, 4 as one pair, 2, 3 as another pair. 1, 4, 2, 3. Add the numbers in each pair, 5, 5, and we got a square. So n can be equal to 2. If I take n is equal to 4, I will get 8 numbers. I'll pair like this symmetrically. This is 9, 9, 9, 9. So the total product is 9 power 4. Again a perfect square. So whenever we have an even number, we can do what he's asking us to do. So n can be any even number in 1 to 37. Now let us look at odd numbers. If I take n is equal to 1, this set will become 1, 2. So if you add this, you'll get only 1 sum 3, which is not a perfect square. So n cannot be equal to 1. Let's see what happens when I take n is equal to 3. I have 6 numbers. If we club these numbers like this, 1, 5, 2, 4, and then 3, 6. Let's see the pairs. 1 plus 5 is 6. 2 plus 4 is 6. I got a perfect square. And 3 plus 6 is 9, which is a perfect square. So n can be equal to 3. So using this particular structure, we can use generate for higher odd numbers. If I take 5, I will have 10 numbers. First 6, we use this structure 1, 5, 2, 4 and 3, 6. There we will get a perfect square. Now from these numbers, we are done with 6. So we will have our regular structure. Here I have 17 into 17. Same thing. If you have n is equal to 6, there will be 2 more numbers. You can club it like this. So from n is equal to 3, any odd number is also okay. So we are getting all even numbers and all odd numbers except n is equal to 1. So n is equal to 1 is the only number which is not allowed. So out of 37, we have 36 possible n's. So the answer is 36. Consider a sequence of real numbers of finite length. Consecutive 4-term averages of this sequence is strictly increasing and consecutive 7-term averages is strictly decreasing. What is the maximum possible length of such a sequence? So let us say the sequence is A1, A2, A3 and so on. Let us take the 4-term average of the first 4 terms. A1 plus A2 plus A3 plus A4 by 4. The next 4-term average will be A2 plus A3 plus A4 plus A5 by 4. These are the first 4 terms, next 4 terms, second to 5th. You can cancel this. This is a strictly increasing. So this average, when you move from this average to this average, the value will increase. So this part I can cancel off and I can write A1 is less than A5. So any term is less than the term which comes 4 terms after that. So similarly, I can write A2 less than A6, A3 less than A7, A4 less than A8 and so on. Now let's go to the next part. consecutive 7-term averages. Let us take the sum of the first 7 terms. This is strictly decreasing. So next it will be greater than the next average. I am cancelling that by 7. A2 and so on till A8. So here A2 to A7 will get cancelled and we get A1 greater than A8. So along with this sequence, I have A1 greater than A8. I go to the next step, A2 greater than A9, A3 greater than A10 and so on. So let's combine these two and see what happens. I'll take the first term, A1. A1 is less than A5. A5 is less than, if I write the next line here, I'll get A5 is less than A9. This will be less than A9. From this one, A9 is less than A2. A9 is less than A2. So far, so good. A2 is less than A6. A6 will be less than A10. I'll borrow here. A10 will be less than A3. I'm checking whether I'm getting any repetitions or not. So far, so good. A3 will be less than A7. Another new term. A7 will be less than A11. A11 will be less than A4. All different terms. A4 is less than A8. Another new term. A8 is less than A1. This is the first time I got a repetition. So what is happening here? I am getting A1 is less than A1, which is not possible. So what we'll do is, here the biggest term is 11th term. So if I can remove this, I can get a finite sequence with all my conditions satisfied. So n can't be 11. So the maximum number of terms we have is 10. So that is the answer. Find the number of ordered triples ABC of positive integers which are lying between 1 to 50 which satisfy this relation. So we'll assume LCM, we'll assume GCD of A and C to be G1 and GCD of B and C to be G2. So let's say A is G1 into A0, B is G2 into B0. LCM is product by GCD. Same thing here, product by GCD by A plus B is equal to 26C by 27. C will get cancelled off here. A by G1 is A0. This is B0. Cross multiply with 27. We get 26 into, this is G1 A0 plus G2 B0. Rearrange with A0s and B0s. We get A0 into 26 minus 26 G1 is equal to B0 into 26 G2 minus 27. These two are positive. So these two should be having the same sign. Also, you can clearly see that 26 divides A0 plus B0 and 27 should divide. There is nothing but A plus B. 27 should divide A plus B. A plus B value, maximum value is 100. So the multiples of 27 will be 27, 54 or 81. Now let us take two cases. These two terms are both positive. First case, 27 minus 26 G1 is positive and 26 G2 minus 27 is also positive. Here I'll get G1 is less than 27 by 26 and G2 is greater than 27 by 26. Here there is only one possibility, G1 is equal to 1. If I put it here, I get A naught is equal to B naught into 26G2 minus 27. This is less than or equal to 50. So this will be less than or equal to 50, or G2 should be less than or equal to 77 by 26. So with this and this, we get only one possible value for G2. G2 is equal to 2. If I substitute this here, I get A is equal to A naught and B is equal to 2B naught. Also, we'll substitute it here. We get A naught into 1 is equal to G2 is 2, 2 into 26 is 52, 52 minus 27 is 25. So I have 25 B naught. So if B naught is 1, A naught will be 25. If B naught is 2, A naught is 50. After that it will become more than 50. So we'll take these two possibilities. So A naught could be 25. 2 into B naught could be 2. This is one pair. Or A could be 50. B naught is 2. 2 into 2 is 4. So 50 comma 4. This is the other pair. So in the case of A is equal to 25 and B is equal to 2, what could be the value of C? C should be co-prime with A because G1 is 1. So you should not have any 5 multiple. So 5 should not divide C. And with B, the LCM is G2, which is 2. So C should be even. So should not be a multiple of 5 and it should be even. What are all the even numbers here? 2, 4 and so on. There are 25 even numbers. We have 25 even numbers. Out of them, there are 5 numbers which are multiples of 5. 20, 10, 20, 30, 40, 50. So remove this 5. So out of 25, we are removing 5. So here we have 20 possible cases. Similarly, I can look at the case when this is negative and this is positive. 27 minus 26 G1 is negative. Sorry, both are negative. 26 G2 minus 27 should be negative. If you observe, it has the same structure. So here if we got 20 solutions, here also we'll get 20 solutions. The total number of solutions is 40. That's the answer. Assume A to be a positive integer, that is a natural number, which is not a perfect square. Not a perfect square. Let x and y be non-negative integers. So they are whole numbers such that this equation is satisfied. What is the largest possible value of A which is less than 100? So let us square this. X minus root of x plus A is equal to A minus 2y root A plus y square. So if I rearrange this, I get x minus A minus y square is equal to, so we'll take two cases here. X plus A is not a perfect square and x plus A is a perfect square. If it is not a perfect square, these two irrational terms should be equal to each other because A is not a perfect square. These are irrational. The remaining part are rational. So equating the rational parts, I get x is equal to A plus y square. Equating the irrational parts, I get root of x plus A is equal to 2y root A. Simplify this, square x plus A is equal to 4y square A. Now from here x is A plus A square, so this will become 2A plus y square, or y square is equal to 2A by 4A minus 1. You can clearly see that this is approximately 1:2. So this is less than 1, which is not possible because A cannot be 0. So we have the second case, x plus A is equal to perfect square. So let us call this perfect square some A square. So what will we get? Here we have x minus k is equal to a minus 2y root a plus y square. Here this is the only irrational part, so it has to become 0 because everything else is rational. So y is equal to 0. If I substitute y is equal to 0, I get x minus k is equal to a, or x minus a is equal to k. Square on both sides, x square minus 2ax plus a square is k square. K square is x plus a. I can write this as a quadratic in x. What is the discriminant here? B square minus 4ac. 4a square gets cancelled and I get 8a plus 1. Here the root is an integer. X is an integer. So the discriminant should be a perfect square again. So I'll call this sum m square. What is the largest value of 8a plus 1? 8a plus 1 here will be maximum of 801, less than 801. And this is an odd number. So what is the largest odd perfect square less than 801? That will be 27 square, which is 729. So a will be 728 by 8 or 91. So the largest value of a is 91. A regular polygon with at least 5 vertices is said to be colorful if it is possible to color the vertices using at most 6 colors, so that each vertex is colored with exactly one color and any 5 consecutive vertices have different colors. We need the largest possible n where the polygon is not colorful. If I put n is equal to 3, I can have 3 different colors and this is colorful. So if you look at colorful combinations, n is equal to 3 is allowed. If I put n is equal to 4, again I'll have 4 different colors. So 4 will be colorful. Similarly 5 and 6 also will be colorful because I have 6 different colors. So any 5 consecutive vertices will have different colors. Let us see for n is equal to 7. 1, 2, 3, 4, 5, 6, 7. Now here, if I put 1, 2, 3, 4, 5, 6, now whatever color you put here, you cannot have 5 consecutive colors of different colors. So when I put n is equal to 7, the polygon will be not colorful. So n is equal to 7 is one case where it is not colorful, but we need the largest possible value of n. Let's do some generalization. You can have 5 different vertices consecutively which have same color, or 6 vertices which have different colors. So you can group them into consecutive vertices which have different colors. So you can have 5 vertices or 6 vertices. Let us say such links, I have A of them, and the links which have 6 different vertices with different colors, let us say we have B of them. So the total number of vertices, which is 5A plus 6B, should be n, where n is the total number of vertices. So this is the general equation. Now you can clearly see that n I cannot generate with this particular structure. Similarly, I cannot generate 8 also and 9 also, but 10 I can generate. I can have 5 plus 5. 11 also I can generate. I can have one link of 5 and one link of 6. 12 also I can generate. 6 plus 6. Again 13 I can't generate. So 13 is not colorful. 14 I can't generate. 15 I can generate. 5, 5, 5. 16 I can generate. 17 is okay. 18 is also okay. So 15 to 18 I can generate. 19 I cannot generate. 20 I can generate by adding 1 5 here. This is 21, 22, 23, and 24. So 20 to 24 I can generate. Now from here onwards, I'll just add one more 5, 25, 26, 27, 28, 29. I can generate all the others. From here, 24 onwards, any number of vertices will be colorful. So these are the only possibilities for the number of vertices where the polygon is not colorful. The largest value of n is 19. That's the answer. Let S be a circle of radius 10 with center O. Suppose we have two more circles S1 and S2 which touch S internally and they intersect each other at two distinct points A and B. Angle AOB is 90 degrees. What is the sum of radii of S1 and S2? So let us say S1 and S2 are like this. They are intersecting each other at AB and they are touching the bigger circle internally. The bigger circle radius center is O, let us say. Here the radius is 10. These two radii we don't know, so let's call them R1 and R2. Let's say these are the centers for these two circles. Now he has given angle OAB is 90 degrees. So I will assume A to be origin, center to be some d comma 0, it's lying on the x-axis. And let us say the centers here are C1 and C2. Now this line segment joining the centers will be perpendicular to the common chord. And this also perpendicular to the common chord. So these two will be parallel. So here the heights will be same. So here let us say the coordinates are x1 comma h and this center be x2 comma h. Now the big circle and this circle are touching internally. When two circles touch internally, distance between the centers should be same as difference of radii. So OC1 is 10 minus R1. Similarly, OC2 will be 10 minus R2. Now look at C1A, that's the radius of this circle. So C1A is equal to R1 and similarly C2A is R2. Apply distance formula here, square, I get x1 square plus h square is equal to R1 square and this one will give me x2 square plus h square is R2 square. So I got one set of equations. Let us square this. What happens? OC1 square will be x1 minus d whole square plus h square is equal to 10 minus R1 square. Similarly, x2 minus d whole square plus h square is 10 minus R2 whole square. So these are our equations. If I subtract these two, I get x1 square minus x2 square is equal to R1 square minus R2 square. Let's subtract these two. I get x1 square minus x2 square, d square will get cancelled, minus 2d into x1 minus x2, h square will get cancelled. We'll do a plus b into a minus b here. When I do a minus b, I'll get R2 minus R1 into a plus b will give me, or if you expand this, we get minus 20 into R1 minus R2 plus R1 square minus R2 square. Now from here, x1 square minus x2 square and R1 square minus R2 square is one and the same. So if you simplify, I get d into x1 minus x2 is equal to 10 into R1 minus R2. Now add these two equations. What do we get? x1 square plus x2 square minus 2d into x1 plus x2 plus 2d square plus 2h square is equal to 200 minus 20 into R1 plus R2 plus R1 square plus R2 square. Now what to do with this? You add these two, we get x1 square plus x2 square plus 2h square is equal to R1 square plus R2 square. If I use this, x1 square plus x2 square plus 2h square will get cancelled off with this. Simplify. You can take minus 2 common. D into x1 plus x2 minus 2d minus d. I'm cancelling minus 2. Then d square is equal to minus 100 plus 10 into R1 plus R2. Do first equation by second equation. We get x1 plus x2 by d is equal to R1 plus R2 by 10. This equation by this equation. We can use that here. x1 plus x2 I will write as d into R1 plus R2 by 10 minus d square is equal to 10 into R1 plus R2 minus 10. So if you, here also I'll get R1 plus R2 minus 10. So I'll get d square by 10 minus 1. Now from here d will be less than the radius. This cannot be 0. So you have sum of radii of the inner two circles is 10. That's our final answer.
I hope you are enjoying our solutions for IOQM. Almost every JEE ranker is started with IOQM and built their foundation early on. And to give you the same early advantage, we have built our JEE Foundation course for classes 8th, 9th and 10th with IIT and faculties from top 7 IITs. Do check it out, linked in the description below, and happy learning.